ゼロトラスト Your Cloud Workload のオンラインイベントへようこそ。Z-Scalar 日本及びアジアを代表しております金田博之です。本日はワークロードコミュニケーションに関する Z-Scalar の新たなイノベーションについてお伝えできることを嬉しく思います。クラウドシフトが加速する中、ハイブリッド環境やマルチクラウド環境でのワークロードのセキュリティは今後大きな課題となります。このイベントで Z-Scaler Zero Trust Exchange の一部となるワークロードコミュニケーションのセキュリティサービスをお客様に提供できることを嬉しく思います。これにより、ゼロトラストのセキュリティがパブリッククラウドでホストされるワークロードとアプリケーションに拡張されます。今回の発表では、クラウドトゥインターネット、クラウドトゥクラウド、そしてクラウドトゥデータセンターのすべての通信を保護するための業界初のクラウドワークロードへのゼロトラストを適用したソリューションを紹介いたします。本日は Z-Scalar CEO 会長兼創業者の J. チャウドリー、そして R&D プレジデントで CTO のアミット・シンハ、さらにはお客様及びパートナー様からはシーメン様と AWS 様にお話をお伺いいたします。このメインセッションが終わった後、Z-Scalar 製品担当シニアディレクター、スマンス・カカラパチからテクニカルブレークアウトセッションを提供します。こちらではハイブリッド及びマルチクラウド環境でお客様が Z-Scalar のソリューションを使用してワークロードを保護するデモを行ってまいります。今回もですね、日本語字幕付きにてご提供してまいります。最後までご視聴ください。それでは始めましょう。
Zscaler welcomes you to Zero Trust Your Cloud Workloads. Here's your host for the event, Zscaler's Chief Marketing Officer, Chris Kozub.
Hello and welcome to today's Zscaler launch event announcing new innovations in the area of cloud security. I'm Chris Kozub and I'll be your host today. Now during the next 60 minutes, you'll hear from Zscaler executives as they discuss how we are extending the same level of security we have traditionally provided to users now to the public cloud. We'll talk about the new innovations we've developed to address common use cases that customers face in securing their cloud workloads and applications. And we'll hear from a customer on how they extended zero trust from users to the cloud as they completed a cloud migration of thousands of their workloads. And finally, you'll also hear from one of our leading cloud partners on how we are jointly working to secure the cloud based on the shared responsibility model. Now, given that this event is live, you have the ability to ask real-time questions of our speakers. It's really easy. To ask a question, just type it into the Q&A window. I'll do my best to incorporate as many questions as possible, and we'll also have a series of real-time polling questions to enhance the real-time interaction for today's session. Now, I encourage you, please stick around at the end of this session to go deeper with a technical segment on Zscaler workload communications. Well, with that said, I think it's time to get this show started. So let's hear from an expert on this topic, Zscaler's chairman, founder, and CEO, Jay Chaudhry. Jay, welcome to the show.
Thank you, Chris. Hello. I'm so excited about launching our next big innovation, Zero Trust for Cloud Workloads. First, let me start with a little bit about Zscaler, the company I started in 2008 with a clean slate, with a clean architecture to securely connect users and applications without requiring the traditional network. And that's where we came up with the Zero Trust Exchange platform. Our platform delivers great user experience, impressive cybersecurity, and tremendous infrastructure cost reduction, all three at the same time. Zscaler now is a public company traded on NASDAQ. We recently crossed $1 billion in annual recurring revenues. Even at that scale, we are growing about 62% year over year. Large enterprises love us. 35% of Fortune 500 companies depend upon Zscaler for their secure digital transformation. And all this is happening for two reasons. One, we have an amazing architecture that's not traditional legacy network and security. Two, our NPS score, 76, I'm the most proud of. This is the best indication of customer satisfaction. We take it seriously. And an average SaaS company has an NPS at about 30. We are widely deployed in almost every vertical across the globe. Let's start talking about the problem we are trying to solve. How many of you have millions and millions of dollars spent on legacy security like firewalls and VPNs? But why are these threats still happening? Well, let's look at the model of network and security that was invented 30 years ago. It was a great model at that time. You built applications in the data center. Cisco was born to help you connect your data center to branches. And then you extended the same network to public cloud. Once you're on the network, you could access any applications. And then you didn't want too many of these security appliances and firewalls. So firewall vendors will start spinning those VMs in the cloud. But keep in mind, a firewall or VPN is a network device. It's an IP device. Your network extends everywhere, wherever your firewalls are. So how do bad guys come after you? First, they find your attack surface. Every firewall, every application, every VPN that resolves to the open internet is an attack surface. The more branches you have with more firewalls, the bigger your attack surface, because that's how bad guys find you. Once they find you, they want to compromise you and establish a beachhead. You are rolling out thousands of workloads. If those workloads are exposed, they could be compromised, because that becomes a starting point, that becomes the beachhead. And our job should be to protect them. Number three, once they compromise a workload, they want to move laterally to find high-value assets. You know, on this WAN, which connects your data centers and all these regions out there, they make it easy to find applications. But it's like Interstate 80. You get on it in San Fran, I can reach New York, Miami, or Dallas without hitting a single light. But bad guys can do the same thing. That's why a single infected workload in one of your regions can essentially infect the whole thing. And then finally, they want to steal your data. That's why any communication that goes out to the internet, if it's done properly with proper DLP technology, you can be safe. I'll show you how we tackle these problems with Zscaler. First, let me have a quick survey, your feedback about how do you look at various type of risks. You got these 4 options. Pick one, and we'll share with you the results a little bit later. We're all talking about zero trust architecture because the traditional network architecture has failed. Remember, you get on the network, you get everywhere. The zero trust architecture really says users and applications won't be on the same network. In this diagram, you see applications as destinations. There are external applications that you don't run and manage. You simply use them. There are internal applications that are sitting in your data center or a public cloud. It doesn't matter. They're simply destinations. You manage them, you secure those applications. And users are all untrusted. If a user needs to access, say, Microsoft 365 from a mobile phone, first, over any network, They come to Zscaler Zero Trust Exchange, and we stop them. It's like, stop, who are you? Let me verify your identity using an identity system. If that passes, the next check, where are you going? You can define applications. Somebody can go to only certain destinations. Somebody can only go to SAP and the like. That's extremely important so people don't wander around on your corporate network. 3, what's the risk? Identity can be stolen. So we use a lot of other contexts. We are looking at device posture, which location is the traffic coming from, and a number of risk-based variables based on behavior and of the traffic. And the policy can be dynamic. If all that passes, we check the next thing. Are you carrying bad things? This is the analogy of the airport. Do you want dangerous luggage on the plane? No, we don't. In the same way, we are inspecting if the user was hitting a phishing link, or maybe there's a zero-day file that was coming and needs to be stopped. And then lastly, we establish connection. This is the Zero Trust architecture, which starts with identity. Device posture plays a role in it, but the policy engine that Zscaler provides is critical. For internal application access, if a user wants to go from a laptop to, say, SAP, the first few steps are different. It's the last step that's very critical. We use connector technology to really start inside-out connection. There's no outside-in connection allowed. That means your applications go dark. They can't find you. They can't attack you. Hence, we minimize your attack surface. That's the starting point. 2, we only connect you to particular applications, not to the network. Hence, there is no lateral threat movement. These are 2 fundamental principles of Zero Trust, and they are the opposite of firewall and VPN security. That's why if you are doing firewall and VPN-based security, you are not doing Zero Trust. Okay. And there are a few other things we do. I won't go into all the detail of it, but this is the crux of Zero Trust architecture. Now, how have we implemented it? Over the past 10 years, we started with protecting protecting users when they access external applications like internet and SaaS. Most of you probably know about ZIA, Zscaler Internet Access, for cyber protection, data protection for users, and then Zscaler Private Access to access your internal applications without getting on the network, without needing any VPN. So you simply connect to application and not to the network. We have large number of customers using ZIA and ZPA, and also a new service called Zscaler Digital Experience that allows you to figure out any performance issues as users are accessing applications from anywhere. It was natural for us to extend this platform where we started with doing Zero Trust for users, and now extend it to do Zero Trust for workloads. And that's really the product, that's the service we are launching today. I'll be expanding upon this service in the coming few minutes. So, what do we need to do about Zero Trust protection? Well, the multiple areas. Let's look at it from cyber point of view. Cyber is not one thing. You need to look at it holistically. First of all, workloads talk to internet just like users talk to internet. So that traffic must go through ZIA cloud service. We'll show you how we have made it so easy for you to send your traffic to ZIA cloud to get the same security you had depended upon for your user protection. It should be applied to workloads as well. Second area, workloads talk to other workloads. Why should they be on the same network? Why not go through the same switchboard? We'll show you how we do that today. And third, then you want to do next level of segmentation, micro-segmentation, so that within a given VPC, only the right workloads talk to the right workloads. And that's the other area. We'll show you about that as well. This is about stopping cyber attacks or cyber threats from propagating. Then the next area we need to worry about it, how do you protect your data so data doesn't leak out? For that, there are few things that need to be done. There's no one single thing you can do it all. We have been offering CASB service to protect your SaaS data in your SaaS applications. And now, recently, we start to offer CSPM and CIEM so we can help with your configurations so no misconfigurations happen to your workloads and there are right level of entitlements and permissions for your users. The next new thing we are launching today is inline DLP because your workloads talk to internet. They could leak data to internet. By being able to make sure that any data going to internet goes through Zscaler ZIA cloud service, we offer you very good inline DLP protection. So, with all this offering, how do we give you holistic security? Well, let's go back to the same 4 things. Remember, we said everything bad comes from the internet. And we have Zscaler cloud service deployed everywhere around the globe in actually about 150 locations around the globe. So you connect to Zscaler. Your workloads, your users, your branches, your data center, they're not exposed to the internet. And your applications aren't exposed to the internet either. Your workloads actually are hidden behind Zscaler. So where is the attack surface? Your IPs are no longer visible to the internet. You go out through Zscaler. If they can't find you, they can attack you. So the number one benefit is we eliminate your attack surface. You are hidden behind us. Number 2, the bad guys want to compromise your workloads. So for valid communication, they may try to sneak in. Since we are like an airport inspection checkpost, we're inspecting all communication that going in and out between the workloads and the internet to make sure we find the bad stuff and block it right there in the cloud so they can't get to your workloads. Remember the third thing? Bad guys like to move laterally to find high-value targets. Well, there's no routable network between the branches and the data center or data center and workloads or AWS East to AWS West. It's all zero trust. You go through us, hence there's no reason why bad guys should be able to move laterally. That's wonderful. That's probably very effective to stop these ransomware threats. Number 4, all bad guys want to steal your data. Since all communication goes through us, we are like an international airport, a checkpost. We can spot anything anomalous, malicious, or anything that's confidential, proprietary being sent out and stop it. So you can see we handle all 4 things. That's how you get very good security for your cloud workloads. Now, as I come to close, let me remind that we believe that you need an ecosystem of good partners, good platforms, so that you don't have to buy 50 things from 50 vendors. You actually select the best of breed platforms. You select your cloud providers. You select your SaaS providers. You'll have your data centers for a while. And you got users everywhere. All communication, users to apps, apps to apps, workloads to workloads, it goes through Zscaler switchboard to make sure the right communication happens. And we integrate with all leading platforms like identity, with leading vendors like Okta and Microsoft, endpoint with CrowdStrike's, Microsoft, and many more. We can take traffic from any router or any SD-WAN device, make it easy to send traffic to Zscaler. And we can feed all the logs to security operations solutions of your choice. So our goal to make sure it's easy for you to deploy and operate all these solutions. So API-based integration plays a big role. Every CIO tells me they're tired of lots of point products. Integrated platform is the answer, and we want to be one of those key platforms. They're very focused on doing one thing and one thing well. Connect right entity to right entity with proper security and work with the rest, with the partners. So why do businesses buy Zscaler service? Well, first and foremost, it is about cyber threats, making sure we don't really let any threats infect our entities and lose data. Our cyber is fundamental. We all worry about ransomware risks. 2, the complexity of all these virtual firewalls, VPNs, and networks is complicated. We can eliminate all that and becomes very simple. And agility is important. Setting up this connectivity, security, takes a lot less time than it would in that traditional approach. So I hope you found this thing worthwhile. And with that, I see we have gotten some questions. We're going to take some questions as it's a live session.
Great, Jay. Thank you. Have a seat, and welcome into the question hot seat. It's great to have you here. You know, it's really impressive to see the Zscaler innovation engine at work, and extending the Zscaler Zero Trust Exchange to the cloud demonstrates the capabilities of our platform to help our customers secure their cloud workloads in hybrid and multi-cloud environments. So Jay, let's go ahead and jump in here. You covered quite a fair amount of ground. We've got a question that has come in from John. And this question from John is Workload Communications a standalone product or something that's licensed as part of other products?
Chris, we like to give choices to our customers. You can start with workload communication on its own, or it could be an add-on to other Zscaler offerings you already have in place.
Perfect. So it sounds like a lot of flexibility that we have as part of this offering based on where the customer is in their deployment cycle.
Indeed.
Jay, another question here we have from Sam, and this question is, are you planning to bundle this with other cloud security offerings? He cites CSPM and CIEM, maybe worthwhile explaining those for our viewers, but do we plan on bundling these?
Yeah, as I said, there's no one single product that protects workloads. You got communication that must be secured, CSPM, CIEM, allows you to make sure the postures are configured properly. We offer both. You can actually buy both of those, or you can actually start with one and move to the other.
Excellent, Jay. So during your session, Jay, you asked a polling question. So we're going to go actually to those results right now. And so let's bring up the results. So Jay, you asked the question, what cloud workload risks are you most concerned about? And the audience answered here, let's see, 24% cited attack surface, 30% lateral threat movement, 14% compromised workloads, and 30% data loss. Yep. So Jay, initial reactions to this data set?
Not surprised. I would have thought that attack surface may be number one, because that's where everything starts with. But if you look at all these ransomware attacks that happen, the lateral movement took the bad guy to the high-value assets. Colonial Pipeline, they got in through VPN, and they moved to the billing application. So every CISO worries about lateral threat movement. Yep. So I'm not surprised that that's there on the top. And the reason data loss doesn't surprise me is because at the end of the day, it's all about protecting your data. But if you do the first three things right, the data loss shouldn't happen.
So it's almost as if you're saying there's obviously an interest in protecting data, but the defense for that is to start by reducing attack surface, reducing lateral threat movement, and then ultimately that's going to have the knock-on effect of protecting data.
Exactly.
Excellent. Well, it's great to have these polling questions. Really gives kind of a, I know it keeps you on your toes and have to answer some of these live questions. So I have a third question here, Jay, for you, and the question is from Sean. Sean states that they have invested heavily in VPNs and firewalls, and you talked a little bit about this in your opening. Sean's question is, how does he convince his CISO that perhaps these investments may need to be revisited?
Yes. You know, these firewalls and VPNs did a good job for a while. I mean, they have served a very good purpose. But this new world of cloud and mobility, it just doesn't work anymore. It's like trying to protect yourself with all these modes when the world has moved on. So I think the best way to really convince or educate people who are still thinking about the old world is really understand zero trust architecture. I'll probably make one more comment here. Since zero trust has become very popular lately, every legacy vendor has become a zero trust vendor overnight. It is easy to create PowerPoint. It's a lot hard to build real products. Right? I was reading an article last week. It said, we are the best zero trust network security vendor. It's like, either you're zero trust or your network security are not both at the same time. Zero trust says don't trust people being on the network. There's no routable network,
Right.
But that's what legacy vendors do. So I think we'll be glad to share architecture workshops and additional information. And the story is very compelling.
Very good. Jay, I'm going to squeeze in one last question here. We've got just about 30 seconds for you. The question comes in from Paul, and Paul says, what about SaaS applications? Can we connect two different application vendors that need to integrate through Zscaler?
Of course, we always offered flexibility. For us, your SaaS applications or internal applications, they are merely destinations. You may have different policies set up in our Zero Trust Exchange based on different applications, but with full choice. In fact, you could actually use multiple identity systems out there. A user could use identity a certain user could do identity B. With that, actually, you can have your third-party contractors, suppliers, and customers also access your applications out there.
Very good. Jay, I'm going to give you a huge thank you on behalf of our viewers. Thank you for being here. Thank you for sharing your insights and your wisdoms. So now let's talk more about today's announcement and pull back the covers to get a little bit more detail on what capabilities we're bringing to market to further help our customers navigate the challenges of cloud security. Now, I can't think of anybody better to do that than Mr. Amit Sinha. Amit is Zscaler's president of R&D, operations, and of customer service. So Amit, over to you and welcome to the show.
Thank you, Chris. Hello, everyone. Jay shared with you why it's important to enable zero trust for workloads. As organizations move their workloads to the public cloud, they're often stuck with legacy connectivity and security architectures. A legacy model typically extends the flat corporate network into the cloud with WAN connectivity, a mesh of site-to-site VPNs, and virtual firewalls everywhere. This model increases the risk of lateral threat movement due to a flat network. A single infected machine can infect everything, as Jay mentioned. The attack surface for threat actors to exploit is increased. Replicating DMZs across clouds and regions adds operational complexity and cost. Users accessing these workloads have to hairpin through the corporate data center, which increases latency, resulting in poor app performance. You have moved your apps to a modern cloud platform, yet your access and security controls remain decades old. Let's take a deeper look into how the legacy enterprise connectivity model works using an AWS example. Workloads in VPCs connect to transit gateways, which in turn connect to an internet VPC that has stacks of virtual north-south firewalls just to connect to the internet. When workloads in a VPC need to communicate with other workloads, east to west virtual firewalls have to be set up and managed. A large global enterprise can have workloads in multiple regions and availability zones. They may have multiple cloud providers on top of that. The legacy network-centric connectivity model results in an explosion of virtual firewalls and proxies and operational complexities of managing a network. The Zscaler Zero Trust Exchange is already protecting millions of users, and we are now extending the same security and policy controls to cloud workloads, whether it's workloads communicating with the internet or with workloads across hybrid and multi-cloud environments. Your workloads are never directly exposed to the internet, dramatically reducing your attack surface. Workloads are naturally isolated from other workloads as they connect based on policies through the Zero Trust Exchange. And operational complexity is reduced dramatically as you no longer have to manage an explosion of virtual firewalls and complex networking. Connecting your workloads to the same Zero Trust Exchange as your users delivers a fast and secure experience for them. Workload communications is extremely simple to deploy and manage. You deploy a lightweight connector that is managed by Zscaler in your cloud VPCs and your data centers. It securely connects them to the Zscaler Zero Trust Exchange. Workloads communicate with the internet using the Zscaler Internet Access Service. They communicate with other private workloads using the Zscaler Private Access Service. Now let's talk about 3 key use cases for workload communication. Zscaler workload communication addresses north-south as well as east-west traffic. Number 1, workload to internet communications. This enables workloads to securely access the internet with full inline security and data protection controls that are available in ZIA. Number 2, workload to workload communications. This enables workloads to communicate with other workloads across public clouds and the corporate data center without requiring them to be on the same network by using ZPA. And finally, number 3, workload to workload communications within a VPC. This enables identity-based microsegmentation for workloads within your VPCs and Vnets without requiring any network segmentation. Now let's hear about what you think, and we can throw in a poll question here. Out of the 3 use cases that I just talked about, which is top of mind for you? You can choose one of the answers, and we'll discuss polling results towards the end of the session. Now let me show you how easy it is to deploy and manage Zscaler workload communications. As a first step, we need to install a connector in your environment. Here, you can see the Zscaler Cloud Connector on the AWS Marketplace. Deployment is fully templatized and automated. Zscaler manages and monitors the connectors as part of the service. Similarly, you can get the Zscaler Cloud Connector from the Azure Marketplace. You can manage all your connectors across multiple clouds and multiple regions, as well as your data centers and branch locations from the Zscaler console. You can monitor their deployment status, their location, their health, etc. Traffic forwarding is fully integrated with the Zscaler service. Forwarding rules use a rich criteria based on locations, applications, and network services to forward traffic to ZIA or ZPA. Now let's talk about the first use case, Zero Trust workload to internet communications. For example, you may have a workload that needs to access certain APIs or software updates from the internet. You can set up policies to safely enable that through ZIA. Here, you can see the familiar ZIA policy screen for URL and cloud application controls. Policies are based on workload location, request methods, URL categories, etc. And it allows you to set very granular policies. This can be as specific or as broad as you need. You may want to block everything and allow only specific destinations for your workloads. You can also enable SSL scanning of content. The key is that all the ZIA policy controls, logging, analytics are seamlessly available for your workloads, just like they were for your users. Let's take a look at the second use case, workloads to workload communication across clouds. For example, you may have a workload in AWS that needs to talk to another service or workload in Azure, or perhaps your own data center. You can set up zero trust connectivity using ZPA. Here, you see the familiar ZPA policy screen. In the policy criteria, you can specify how workloads communicate with each other using application segments and connector groups. Connectivity is brokered through ZPA based on policy, with access decoupled from being on the same network. Once deployed, you can monitor throughput, active sessions, and the health of all connectors in real time. You can drill down into detailed traffic patterns for any connector and get real-time as well as historical views of traffic and session logs. All workload communication logs are natively integrated with Zscaler's logging service, giving you a single console for reporting and analytics, whether it is for your users or your workloads. And finally, let's take a look at the third use case, workload to workload communication within VPCs and Vnets. A modern approach to microsegmentation is based on strong identity at a process level and zero trust connectivity without requiring traditional network segmentation. We start by fingerprinting the identity of every app and process automatically and collecting information about how apps are communicating with each other. These fingerprint attributes are used to verify that only authorized entities are communicating with each other. Using sophisticated machine learning algorithms, communication patterns between apps are analyzed and automated segmentation policies are recommended. In this example, the system has identified all applications that are communicating with Active Directory. To generate policies, all you have to do is click Auto Segment. By default, we protect all inbound, outbound, and internal communications from that segment. In just a few seconds, our workload segmentation solution builds strong identity-based policies. And now, every communication is validated using machine and software identity to ensure that only approved entities can communicate with Active Directory in this particular example. We also measure your attack surface before and after auto-segmentation to help you quantify the risk reduction. For example, here you can see that Active Directory services were reachable by 11,600 network paths. After auto-segment policies were applied, only 86 were allowed. That's a 135x reduction in the attack surface. That was a quick summary of how Zscaler's Zero Trust for workload communication works. It provides 4 compelling benefits and rapid time to value. To reiterate, number 1, it eliminates the attack surface and prevents lateral threat movement across workloads. Number 2, it prevents compromise of workloads and data loss from them. Number 3, it simplifies multi-cloud workload connectivity. Number 4, it is faster and easier to deploy and manage. And with that, I'd like to join Chris and answer some of your questions live. Thank you.
Amit, great. Welcome into the hot seat. Jay seemed to survive the hot seat just fine. We'll see how you do. We've got questions that are already coming in. As a reminder, if you have a question based on this topic and you would like us to answer it live, please go ahead and submit it into the Q&A box, and we'll take that here directly within the studio. So, Amit, first question comes from Manu, and Manu is obviously has followed what you're talking about. He asks, does it protect east-west traffic within a VPC?
Yeah, the short answer is absolutely. I just talked about our workload segmentation solution. It is absolutely designed to use a modern identity-based micro-segmentation for your east-west workload communication. You don't have to rely on traditional network-based segmentation, such as leveraging VLANs or putting east-west firewalls. We all know that doesn't work. It's cumbersome to manage. Using modern identity-based micro-segmentation, you can say, well, here's my UI process, and here's a database process that it needs to talk to, and you assert strong identity and allow only authorized communication between the two.
Excellent. That was certainly a very detailed answer. I'm not going to pretend that I can go toe-to-toe with you on this topic. But let's carry on with the next question. And this question comes from Manoj. Manoj, thank you for your question. Manoj's question is, does SSL decryption work for cloud workload inspection?
If that was Manoj Apte, he probably already knows the answer. The short answer is yes, SSL inspection works for workload communication as well. As I mentioned during the talk, all ZIA services are identically available for users and workloads, and SSL inspection is a core requirement today because we know that most of the threats and data loss happens within SSL encrypted sessions. So if you're not looking into encrypted content, you will miss most of the threats and you won't be aware of what's leaking out.
Perfect. Now, Amit, during your session, you asked a polling question, and we have the results of that poll. So let's go ahead and pull up the results and review what our audience has said. So as a reminder, we asked you the question, which use case is your top priority in this area? And so, Amit, you can see here 41% identified workload to internet, 31% workload to workload across clouds, and then 28% workload to workload within VPCs. So let me ask you, the 41% here, this is obviously the top use case. Yep. Does this gel with what you're seeing?
Yeah, I think that's the logical first place that most organizations start. You move some workloads to AWS or Azure or GCP, and some of these workloads need to talk to the internet. And you saw how cumbersome the complicated the legacy connectivity model is with with transit gateways and internet VPCs. Having these workloads talk to internet-based destinations for API or for software updates is a very logical thing that most organizations need. And being able to do that safely, securely, in a fast manner through the Zscaler internet access service that they're used to is a natural first step, so I'm not surprised.
So let me kind of carry on from that question. So the 28% of respondents here who identified workload to workload within VPCs, does this suggest that they are more advanced or they're dealing with maybe specific applications? What would be the driver for them to have this as the top priority use case?
I think you start with workload to internet, and then as you get more sophisticated in your zero trust journey, you start getting into workload to workload segmentation based on identity inside the VPC. So it's a journey. Zero trust is not an overnight thing, and you start with basics like securing access to the internet. Then you start working on how do I have cloud-to-cloud communications or cloud-to-data center communications, and then I think getting into the VPC is a natural third step.
So this is almost a commentary on progression or the journey that we'd expect many of our customers to go through.
Right.
Excellent. Amit, we're going to jump right back here to the questions. I've got a question that came in from Brian, and Brian states, let me just find Brian's question here. Brian states, we are a current Zscaler customer using ZIA, ZPA, and Silver Peak, now part of Aruba, at our branches for local breakouts. Would this complement or replace the relationship between Zscaler and Silver Peak, which is an SD-WAN oriented relationship?
Yeah, it complements the solution. SD-WAN is a modern, smart, cloud-controlled way to send traffic to Zscaler. You can set it up using APIs that Silver Peak use automate provisioning of traffic from branch locations to the Zscaler cloud. But it's a complementary solution. SD-WAN is just a traffic forwarding mechanism to the cloud as far as Zscaler is concerned.
Very good. I'm going to keep rolling here. We've got more questions coming in. This question comes in from Paul. Paul, thank you for your question. What if the workloads are in my physical or traditional data center? Can Zscaler be used in this case to remove the dependency on internal firewalls?
The short answer is absolutely. You can drop in the Zscaler connector into your data centers that connects to the Zscaler Zero Trust Exchange. Your cloud workloads connect to the Zero Trust Exchange, and you don't need any firewalls. That's the whole point. You're eliminating an explosion of virtual firewalls and proxies as you're expanding from your data centers to a bunch of these VPCs in public cloud.
Yeah, and Jay in his session certainly talked a lot about how network security does not equal zero trust, right. And obviously a lot of the challenges with legacy technologies. We've got time here, Amit, for one last question. This question comes in from Scott, and Scott asks, like ZIA and ZPA, two of Zscaler's offerings, will this solution be available in GovCloud for federal, state, and local customers?
Yeah, the short answer is yes. All Zscaler commercial cloud services eventually show up in our federal cloud. There might be a little bit of lag as we have to go through complex certification processes such as FedRAMP. But the short answer is yes. It's a bit of a lag between commercial and federal.
Fantastic. Amit, I'm not going to let you off the hook just yet. I got a late addition here from David. David, thanks for your question. David asks, how long is data that is decrypted stored in your environment? If you were compromised similar to SolarWinds, how affected are the customer's data sets?
Okay. So the first thing I want to mention is what is it that we store? We're not storing your content. We are storing logs. Logs are metadata of activity. It says this workload at this time talked to this destination, or this user at this time went to this SaaS application. We're not storing the contents of those transactions. That's number one, an important point to remember. Now, those logs are generally stored for a period of 6 months, and they are available in Zscaler's forensic log service. And all the analytics and machine learning and everything else that we do is powered by that. At the end of 6 months, they are safely purged, and we've gone through many compliance and regulatory requirements to make sure that that's done in a safe and secure way.
Wonderful. Amit, we have a number of other questions that have come in. Unfortunately, we're out of time. So, Amit, I do want to thank you for joining us today. Thank you for sharing these insights. And also, congratulations to you and your team. I know that getting to this point of launching these innovations takes a lot of effort and hard work. So you must be very proud today to realize this accomplishment. So congratulations to you and the rest of the team.
Yeah, thank you, Chris. And we are very excited about this launch, and I'm looking forward to our customers getting all the benefits from it that we talked about.
And that is the name of the game of why we're here today. So now let's hear from a Zscaler customer, Siemens, on how they have used workload communications in a real-world environment to solve their challenges.
My team is integrated into Siemens outbound connectivity global IT infrastructure management. It is currently managing hundreds of thousands of workload internet access across all Siemens sites and data centers. We provide a consolidated service to constantly support our rapidly growing infrastructure, users and businesses to have the best experience when accessing the internet, making sure that we keep security and compliance for the company. In terms of goals, the first is, of course, to increase compliance and securely move applications to public cloud. The second is to provide business units the flexibility of choosing their public clouds for the right applications. It is important to gain visibility into these multi-cloud environments. The third is to reduce legacy infrastructure-related capital and operational costs, of course. In terms of challenges, of course, the approve, deny lists and open source proxies are very hard to maintain. The lack of consistent enforcement of security policies across cloud infrastructures and across managed cloud applications compared to our premise infrastructure is the first challenge. The second is the traffic backhauling from public clouds to the data center increases the load on internal resources and also increases legacy infrastructure operational costs. The last is even for the first phase of securing more than 15,000 workloads across 2,000 cloud accounts, the cost and complexity with the multiple point products was quite prohibitive. In terms of the solution, our goal is to build on the success of Zscaler's Zero Trust Exchange, that is securing more than 350,000 users at Siemens. Today, we are now leveraging the same ZIA and ZPA services by deploying cloud connectors from Zscaler to secure workload communications to the internet. These cloud connectors are deployed within minutes using Terraform scripts. We simply point the traffic from the workload to these cloud connectors, and Zscaler extends the connectivity only to the required destinations as defined by our business policies. What we see as benefits are four main that are defined. So the first one is, of course, the stronger security. We will be able to secure all internet-bound traffic globally. Or workloads don't get compromised when connecting to the internet with Zscaler. It inspects all content, including encrypted traffic, applying powerful cyber threat defense and data protection controls for all enterprise, including both users and workloads. The centralized control plane with a simple direct route to ZIA makes it very easy to enforce compliance of security policies. The second is simple connectivity. We will no longer need to backhaul traffic between cloud and data centers, which will simplify workload communications. Direct internet connectivity and multi-cloud connectivity will reduce hops and latency. The third one is scalability, of course. We'll have more a solution which is more scalable. This Zscaler solution will enable secure communication among more than 15,000 workloads across AWS and Azure in multiple regions. Just like Zscaler has scaled our more than 350,000 users at Siemens, we are confident that this solution will meet the needs of our rapidly growing cloud workloads. The last one is, of course, the reduced cost and complexity. We will consolidate multiple products like script proxies, firewalls, NAT gateways, URL filtering, and more. We will also be able to reduce internal network resource consumption by avoiding traffic backhaul to our data centers. In addition, we can standardize and automate security policies for both users and applications, regardless of where they are located. The relation with Zscaler is great. So Zscaler is an innovative market leader, as demonstrated by its latest innovations of bringing cloud security and zero trust to cloud workloads. We are in the process of implementing this and other use cases such as workload to workload across multiple clouds and within VPCs or Vnets to further strengthen our cloud security. We'll look forward to continuing our strong partnership with Zscaler.
Wow, you know, it is always so inspiring to see how these technologies come to life in real-world examples. I just want to express a big thank you to Rui at Siemens for sharing those fantastic insights. It's really great to see that, and congratulations on the progress. Now, I'd like to introduce our next speaker, Punit Minocha. Punit is the Executive Vice President of Business Development here at Zscaler. And he's here to tell us more about the work that Zscaler is doing with some of our technology ecosystem partners to build joint solutions that accelerate cloud migrations for our customers. Punit, welcome to the show. It's great to have you here.
Thanks, Chris. It is great to see our customers getting the benefits of stronger security and simpler connectivity by using Zscaler's Workload communications powered by Zero Trust Exchange. As we all know, the security model in the cloud is based on a shared responsibility, where the cloud provider is responsible for the security of the underlying cloud infrastructure, while the customers assume the responsibility of securing their workloads and applications in the cloud. Building secure connectivity across multi-cloud and hybrid architectures is challenging the part of the enterprise responsibility. As we have heard from Jay and Amit, extending the network security products like VPNs and firewalls simply extends the corporate WAN, exposing attack surface and increasing the risk of lateral threat movement. Hardening your environment to safely and securely move to the cloud can be time-consuming and error-prone. Our goal is to take care of this heavy lifting with our Zero Trust Exchange, so you can focus on your core business. To achieve this, we are closely working with all the major cloud providers to offer compelling solutions that enable our customers to fulfill their share of this responsibility. I'm happy to share that our solution is already available for Amazon Web Services and Microsoft Azure workloads. We deliver a network-agnostic Zero Trust fabric that works over AWS Direct Connect and Azure Express Route to secure cloud workloads for our customers. And last, but not the least, our cloud-ready security solution is available on cloud marketplaces, making it easy for our customers to buy, deploy, and manage very quickly. Let's hear from one of our partners, AWS, with whom we share a common belief in the shared security model and how our combined approach extends Zero Trust architecture to accelerate workload migration and secure workloads on AWS.
Hi folks, this is Merritt Bear. I am a principal in the Office of the CISO, the Chief Information Security Officer here at AWS Amazon Web Services, or the cloud. I'm really excited to be here today to share with Zscaler their announcement of this new workload communications product. I think it's really important that we highlight why this matters. So as you know, when you are working in the cloud, your cloud provider maintains the stack that is the cloud proposition, right? The bottom layers, so we're talking about the guards and gates, the concrete floor, up through layer 4, the hypervisor. And above that, layers 4 through 7 are your software layers that you, as the customer, are making security decisions around, and you're the ones who know what you're doing in there. So that's really important, and it's critical that folks, as they're doing security in the cloud, understand that shared responsibility model. One of the things that Zscaler is offering today is this move from what had been their user to more of a workload-centric, what they are terming a zero trust model. And by that, what they're offering here is a proxy architecture that stops the connection, verifies the security, and doesn't have a lag time. So it's given those 150 points of presence they have around the world, they actually have a custom stack built for this that is very cloudy in the sense that it can be built to scale. So they're doing single packet, non-copy inspection process with a DLP processing too. This is a really neat aspect of what you can take advantage of on your side, the customer side of the shared responsibility model when you're architecting for and securing those workloads. So in a sense, this is also really neat because it's in a playground until it's verified, and Zscaler is continuously feeding their threat models. So you're benefiting from what they learn from around the ecosystem. And part of this reflects our belief inherently as companies that there needs to be a democratization of security, that it is everyone's responsibility and ownership resides everywhere, not just in the security team after the fact. But also that the secure thing to do needs to be an easy thing to do, that we as the security team need to make it the easy thing to do, and that the user experience is really paramount because we care so much about making security democratized and able to be consumed easily, and that way we will make sure that we get to an end state we all believe in. Again, you can find this in the marketplace on AWS, which, as you know, is so easy to do. And finally, looking forward to continuing to partner with you as customers, as partners. And you can find me online on Twitter at @MerrittBear or on AWS. Thank you so much. Take care.
Thank you, Merritt. That was a great overview of how Zscaler and AWS are working together to help secure your cloud migrations with solutions available for a wide range of workloads and use cases. Thanks for joining us today. Chris, back to you.
Great. Well, thank you, Punit. It was great to also hear that from our partner, AWS. It's really clear that our ecosystem continues to play a strategic role in helping our joint customers secure their workloads as they start moving more and more of their applications to the cloud. Well, like all good things, this too has to end, and that does bring us to the end of the main session for today's announcement. I would like to thank each of you for spending your most valuable commodity, which is your time, to join us and learn more about these innovations. Now, a couple of key things to keep in mind. First and foremost, directly after this session, we will kick off a technical breakout session that will allow you to really get into the specifics about this announcement. So I encourage you to stick around and go through that breakout session. A lot of good information within that. Also, should you be interested in a demo, please visit us at zscaler.com. We'd be happy to set you up with a deeper dive and showcase a lot of this emerging technologies directly to you or your teams. Also, I encourage you to visit the Zscaler Cloud Connectivity Solutions page on zscaler.com. That page has a lot of great information, and you can also view things like data sheets and solution briefs that, again, will help you come up to speed in this emerging area. Again, as I've said before, please do take time to complete the survey so that we can make sure that the next event, we just do even that little bit better than we've done today. Your information, your feedback is highly valuable for us. Now, the final plug for me is to mark your diaries coming up in June of 2022. We're going to be getting together in Las Vegas at our Zenith Live, which is our customer and partner event. You can find out more information at zscaler.com/Zenith Live. We'll have both in-person and, of course, virtual options for you to engage with us. Well, with that brings us to a close. Again, don't forget that technical deep dive coming right up. I'm Chris Kozup. Thanks for joining us.
Hi, I'm Sumant Kakarpati. I'm Senior Director of Product Management in Zscaler for Zscaler Cloud Protection. Welcome to the Zero Trust for Cloud Workloads. Before I go into the use cases, Zscaler Zero Trust is not new to Zscaler. We have been doing Zero Trust for user to application access, and with work from anywhere, that has been very widely adopted. When we looked at workloads, we thought workloads should be mirror images of the users. So if we are doing Zero Trust for user to application access, we want to take the Zero Trust for workload to workload access and workload to internet access. So in this session, we are going to talk about 3 key use cases: workload to internet communication using Zero Trust, to workload communication across cloud regions using Zero Trust, 3, workload to workload communication within VPC using Zero Trust. Now let me go through the first use case on how we deliver workload to internet communication using Zero Trust. Use case 1, workload to internet communication using Zero Trust. Unlike legacy approaches, where all the workloads come to a transit hub, and there is a whole set of firewalls, a sprawl of firewalls actually enabling doing security posture before connecting to the destination, Zscaler takes a different approach. Zscaler provides a lightweight gateway to connect to the Zero Trust Exchange, and your entire security posture is running in the Zero Trust Exchange. So what this means is you won't have the barrage of firewalls, split proxies, sandboxing, and all the security services in your AWS or Azure environment. You can run it in a consistent and a comprehensive way in Zero Trust Exchange. We provide 2 things with this. 1, we protect your data. 2, we protect your workloads accessing the internet. So let me walk you through a demo where we go through how simple it is to actually deploy Cloud Connector in your environment. Now let's go to the demo. Zscaler Cloud Connector is available in your AWS and Azure environment. To enable Cloud Connector in your AWS and Azure environment, we provide full automation to connect to the Zero Trust Exchange. So let me walk you through the steps that are involved in enabling Cloud Connector for your environment. So when you go to the Cloud Connector portal, you can see on the dashboard the deployment status and the number of active Cloud Connectors. And you can also see different regions, whether it is AWS, Azure, or data center. You can see all the different AWS and Azure regions from where you can actually deploy Cloud Connector. So in order to deploy the Cloud Connector, the first thing that you need is a provisioning template. So you can go to an administration tab and then click on provisioning template. Provisioning template is a boot up template that is actually given to your AWS or Azure, AWS AMI or an Azure instance. Cloud Connector uses this to connect to the Zscaler cloud, and it registers itself. And once it registers, all the operations and policies are done through the Zscaler Zero Trust Exchange portal. So in this case, you can create a generic template. Next, you can select the cloud provider. It can be AWS or Azure. You can select the location template. This is the default parameters for your template. You can select if it's a small, medium, large, depending upon the capacity that you are looking for. And once you are done, this is pretty much it. Your template is ready. You can use this template in your CloudFormation or Terraform scripts to bring up your Cloud Connector in your cloud environment. So we support, if you go through the administrator tab and you go into automation scripts, deployment template, you can see we have full AWS support with CloudFormation and Terraform. And in Azure, we support a managed app. And you can also enable Terraform to deploy this and integrate it into your CI/CD pipeline. So once you have this available, in this workflow, I will actually show you how to do this with the CloudFormation. You take certain basic parameters, the VPC ID, the availability zone, the subnet in which you are deploying, and the instance type that you want. And the key pair, you can use your existing key pair or create a new key pair. And then you will copy the provisioning URL that you have created earlier. And you are ready to go. So this is pretty much it that you need to deploy Cloud Connector in your environment. So once you have this fully deployed, the Cloud Connector automatically shows up on your dashboard. When a Cloud Connector shows up in your dashboard, it registers itself. It could be coming up from an AWS environment. It will tell you which VPC ID, which availability zone. If it is coming from an Azure environment, it will tell you which Vnet and which availability set it actually belongs to and what's the IP address and so on and so forth. So there is no other configuration. Once the Cloud Connector, it's superbly simple and very fast. The moment a Cloud Connector is deployed, it registers with Zscaler and it is ready to go. So once this happens, you can enable forwarding policy on the Cloud Connector. So there are 3 different forwarding policies that we support. So let me go to policy and enable traffic forwarding. Cloud Connector supports 3 forwarding methods. You can send your traffic to ZIA if you are reaching internet destination, where you run data protection and workload protection stack on your services. If you are connecting to private workloads, you can enable zero trust policy on your workloads to connect to the private workloads in your data center or in another cloud. Right? If you don't want to send it through the Zscaler, for example, if you have a public trusted endpoint like an S3 bucket on AWS that you don't need to send it to the Zscaler, you can enable direct and it will allow you to bypass the traffic and reach that S3 bucket directly, right? So you can have a forwarding method of direct, or you can say ZIA, and then by default, it will select the default gateway, the Zscaler POP that you can connect to, and you are ready to go. The reason why this is so simple is a lot of things are happening on the back end, which actually delivers a better performance for you. For example, depending upon the region that you are actually connecting, Cloud Connector has built-in intelligence to select the POP that is the right POP for you, the right Zscaler POP. It actually connects to that, monitors the performance, and then gets the security processing done on that POP, and then go to the destination. So the connecting to the POP that is close to your proximity, depending upon if you are in US East 1, US West 1, or whichever region and availability zone you are in, and then getting the entire security posture there before reaching your destination is something that that is enabled automatically for you, right? And you also have a direct method where you can say for specific S3 bucket or a whitelisted application based upon FQDN, and so you want to bypass it and you want to send it to the destination directly, right? And all of this is actually logged. So what you will see is any traffic, any and all traffic that is leaving your cloud is actually logged using Zscaler logging, right? If you go to Session Insights, you can see all the traffic that is going to ZIA if it is internet destination. If it is a trusted destination, you can see direct. And if it is a private destination, you will see ZPA depending upon the forwarding method, and it can connect to that destination. Now, let me show you how the security policy is applied on ZIA portal. This portal that you are seeing here was used, you might have used it for your user protection. You can enable all the services that are actually available for your user protection for your workloads. So all data protection services, whether it is data loss prevention, bandwidth control, SSL inspection, URL filtering, IPS, FTP control, advanced threat protection, everything is actually available at your service. So you are not enabling any of these services in your AWS environment. From your AWS environment, you are simply connecting to the Zero Trust Exchange. And Zero Trust Exchange, you have all these services at your disposal where you can enable the services of your choice, right? So you can protect your workloads and you can protect your data by enabling these services. To enable this service, let's take URL filtering. It's pretty straightforward. The same policy, all the bells and whistles that are available for users are available for your workloads. So once you have this available, you can say, I need to, you want to take out stop web category or web communication. You want to block them, have a control policy. And then when you click on the locations, you can see your VPCs because it's a single unified control plane in Zero Trust Exchange. You can see all your VPCs and Vnets available when you look at the locations. So most of our customers today, what you saw in Siemens and other customers is where they have the same security policy that they have for branch data center, and the same policy is actually carried over for AWS, Azure, and other cloud environments. So your security policy is always consistent, it is comprehensive, and it is same exact data plane that is actually running in all the cases, right? So this gives you a very powerful way to secure your workloads, and the location of the workload is irrelevant. The workload can today come from AWS, tomorrow they can move to Azure, and day after it can go to a private data center, Google or somewhere else. But your security posture doesn't change. Your Zero Trust Exchange is actually protecting you no matter where your workloads are connecting, right? And once this policy is enabled, you can see any policy violations, any and all policy violations for your VPCs too. Apply filter. And the logging will tell you exactly which VPC the workload made an outbound connection where it made, and if it's allowed or denied, and if it's blocked and why it is blocked and so on. This is like a user connectivity. The only difference is now we have this available for your workloads in your AWS and Azure environment. So in this use case, we're going to talk about workload-to-workload communication in a multi-cloud environment. This is pretty foundationally different from a legacy approach. In a legacy approach, there is always a network connectivity to begin with. And then once there is a full mesh network connectivity, there are certain firewalls to enable layers of security. That's similar to what Amit mentioned earlier in his session. In a zero trust approach, it's a non-routable network. What we mean by that is each of these environments are isolated by themselves. So there is no network connectivity to begin with. So that makes it very difficult for attackers because there is nothing that is actually visible. So particularly, this eliminates a complete attack surface. And since there is no IP-based connectivity, all the problems that come with IP-based connectivity also get eliminated. For example, IP overlap issues, route scaling issues, route redistribution issues. All these issues don't exist in a true zero trust world. In this world, with zero trust, all you are saying is, I want a particular workload communicating to another workload somewhere else. And we really don't care in which network or which environment that specific workload is. Right? So that's the core concept, the core value of zero trust. It's more about a software entity trying to communicate to another software entity, and there is no networking or no routed network between these two environments. They're just connecting to the Zero Trust Exchange. And if the policy is verified, then these two software entities, if the trust is verified, then these two software entities can communicate to each other. What we'll do in this demo is we'll go through the workflow. We talked about provisioning. It's the same cloud connector, same provisioning workflow. If you have a cloud connector already deployed, provision for ZIA use case, you can use the same cloud connector and the same forwarding policies apply. We can directly go into the ZPA policy and then see how we can define policy between two workloads in different cloud environments. What we're going to show here is workload-to-workload communication, how we can enable zero trust communication between the workloads in a multi-cloud environment. So what I'm going to walk through is since we covered the provisioning aspect of it and forwarding aspect of it already, I will walk you through the policy piece for workload-to-workload communication. So in the policy, we'll go to the administrator tab and then click on access policy. In the access policy, until now, we have zero trust policies for user to application. With Cloud Connector, now you can go beyond user. Doesn't matter where your workloads are. Similar to user anywhere, you have this workload anywhere. Doesn't matter which cloud you are actually connecting from or where your destination workloads are. You can enable a very simple policy that says that I want this particular workload in these VPCs to connect to a specific application. Right? So let me go through the details of that. In this case, what you are trying to illustrate is you can select when you click on the Cloud Connector group, you can actually all the Cloud Connectors and all the VPCs where the Cloud Connector is deployed will just appear on your portal. So you can have a policy that says, from this VPC, I want to connect to a specific application in your AWS specific application, and this application could be anywhere. This could be in AWS, or this could be in Azure, or this could be in your data center. So it really doesn't matter. So essentially what you are doing is you are eliminating any network connectivity between them, because I did not do any network connection here. So if you are in AWS environment, we did not share the routing of your AWS environment with your Azure and from your Azure to AWS, or none of that happened. All we did is the Cloud Connector connect to the Zscaler Zero Trust Exchange. So once it connects to the Zero Trust Exchange, we are enabling a policy that says that this software entity can talk to a different software entity, right? Now here, these internal applications can actually be in data center today. They can move to AWS, Azure, or somewhere else. It really doesn't matter, because the policy is a zero trust policy, which says that this particular source can talk to a destination using zero trust. Now I can save the policy, and you can see that I have a policy that says that this VPC, where I have my Cloud Connector, can only talk to these internal applications, right? So if you go through the live logging, you can see this particular VPC communicating to a specific destination of your workload, right? So it says that the client type is Cloud Connector and the action is allow. And this is coming from the Cloud Connector going to that specific destination. So you can see all of that information here in terms of saying which entity is actually connecting, which VPC is actually connecting to your destination. Use case 3. In earlier use cases, we talked about zero trust for workload to internet and zero trust for workload to workload communication in a multi-cloud environment. In this use case, we'll talk about zero trust for workload to workload within a VPC or a Vnet environment. In this use case, we take zero trust to a much more granular level, inside a VM at an individual process level. We generate software fingerprints at an individual process inside these VMs. And we use this identity to create a true zero trust policy, neutralizing any lateral movement of threats. In this demo, I'll walk you through 4 steps. Step 1, we'll show you how simple it is to enable an agent on your virtual machine. Step 2, we'll show how the software fingerprints are generated at an individual process level inside the VM. Step 3, how the automated ML creates a policy for you. And step 4, we'll show you the visibility for policy enforcement and policy violations. Let me walk you through the demo for workload segmentation. In this demo, what you can see is how the identity-based communication will actually eliminate any possibility for lateral movements of threats, right? If you look at traditional methods of doing this, having static firewall rules and so on, you can always piggyback on that. If you see how we are doing with identity-based segmentation, you can clearly see it's almost impossible for any attacker to just tag on to an existing policy, because we continuously monitor and learn from it and then give you an automated policy that needs to be enabled for your system. So let me walk you through the details. So what you are seeing is a Zscaler workload segmentation portal. So let's say you have your Active Directory here. The first thing we want to walk you through is the provisioning. So in order to enable this micro segmentation, you need an agent on your workloads. So let me walk you through. So you can, this is pretty automated. You can download, and we support Ubuntu, Windows, CoreOS, Debian, all kinds of OS flavors. And you can enable this agent on your environment by downloading this agent, right? So once you have that, the first thing that we do is we collect the inventory. And the inventory is something where we look at it at a process level. If you look at through a process, take any process here. So if we look at this process, we do software, what we call it as software fingerprinting. This is very important to get the true identity at a process level. because when we do this software fingerprinting, we take around 31 different attributes to create a very strong fingerprint. Once this fingerprint is actually created, we use that in our policy. So the first thing is you create the software fingerprint, and once the fingerprint is ready, you can see how the connections are currently existing. So this is actually very interesting, because what you can see here, so let's take Active Directory, right? In Active Directory case, what you are seeing is there are around 10,000 network paths that are discovered. There are what that means is you have 10,000 different ways to connect to this service. But really, in reality, only 69 are actually used, which means there is a big scope of lateral movement of threats where there are 9,931 ways for you to actually get to this service, right? So once our agent is enabled on your asset, it actually finds out it scans and finds out all the different ways for you to get to that asset. This is very critical because that gives you your exposure area. So once you have that, what we can do is we can show you all the different entities that are trying to connect, or all the possibilities where you can connect, right? So let me walk you through that. Let's look through map connections. In the map connections, what you can see here is take a specific application. So let's say DNS, and it actually shows you for this process, and this is not at a VM level, this is an individual executable, individual process level, all the different ways for you to get to this process, right? So this gives you a good idea of, okay, hey, there are like 10,000 different ways for you to get to this process, which you never needed, right? There are only 64 legitimate connections that are actually happening. All the rest of them should not be open to begin with, right? So once you have this, we can enable a policy and segment it. So let me go through those details. So let's take Active Directory and enable policy here. So you can highlight Active Directory and enable auto segment. Auto segment is our ability to learn from the backend on saying what are the actual communications that are required, and then we group them and we present groups of legitimate connections for this particular process or a service. So this eliminates the exposure that you get with lateral movements even within the VPC, where you are saying is we discovered, hey, there are 10,000 different paths. You are not using any of them. You are probably using less than 1% of it. So our ML engine comes with a recommendation saying that I can segment it out for you so that only the necessary processes are actually communicating to each other. And we prune out all the other non-essential paths to this process. So once you have this, you can enable continue, and you can see I can enable the policy is automated. You can enable inbound, outbound, even within the VM. If there are too many communications, you can actually say, okay, what is actually required, right? So once you have that, you have a simulation option where you can say auto segment, and that's pretty much it. It's as simple as it can get, where you are not dealing with static firewall rules at an individual process level. All you are saying is, hey, these are the legitimate connections that you care about, and all the rest of the connections, you can prune it out. So once you have this, the policy is ready to go. It actually gets the related objects, it retrieves the ML recommendations, and it applies the policy, and you're pretty much done. So once the policy is enforced, you can see here a very detailed summary of the paths that are actually protected, and the groupings and the segments that are generated, and the policies that are actually generated for you automatically to protect these paths. So all this is actually done by a couple of clicks, where the ML engine learned all the different paths that are available and then came up with the recommendation. And once you have the recommendation, you can enable it. And when you enable it, you have an option to simulate it, where it will simulate and show you what are the connections that it pruned and how will the new policy will look like. Right? Now, as you can see here, the Active Directory earlier, it's not protected. Now it is completely protected. And you will see all the applications, all the unnecessary communications are completely pruned, right? You are focusing more on the ones that are actually used versus all the other network paths that were discovered but that were never used. So all those connections are pruned. So if you want to see at an individual service level how this is enforced, in this case, if you go to DNS, it will clearly say the connections that are actually allowed and the connections that are actually blocked, right? So this gives you a very good insight on what connections are allowed based upon your policy and what are the connections that are blocked on your policy, right? And if you want to see any of the events with respect to which connections are allowed and which connections, which policy violations have happened, you can go into events, and then you can clearly see the individual events, like who accessed this host, when did the last access happen, and this is a simulated block. It says that, okay, this connection should have been blocked and it doesn't look right, and it will give you a detailed logging information to tell you exactly what are the events, who did the policy violation, how many times it happened, and so on and so forth. So you get a complete view into the system. Just to summarize, we have covered 3 use cases: workload to internet communication, workload to workload communication in a multi-cloud environment, and workload to workload communication within a VPC or Vnet. By moving away from legacy IP and firewall networks to a zero trust architecture, we have demonstrated you can protect your workloads and data much more effectively, and 2, you can eliminate any attack surface, and 3, you can stop lateral movement of threats. Thank you for this opportunity. As a next step, I would request please fill out the survey, and if you need more information, go to zscaler.com/cloud-connectivity, and if you are interested in a proof of value, please reach out to Zscaler sales rep. Thank you and have a nice day.
本日はゼロトラスト Your Cloud Workload にご参加いただきありがとうございます。イベントの内容はいかがだったでしょうか。組織の重要なビジネスのクラウドワークロードを保護し、マルチクラウド接続を簡素化するためのヒントとなる情報を得られたことを期待しております。ビジネスを加速し、そしてデジタルトランスフォーメーションを推進するためのクラウドの活用、そして安心してクラウドコミュニケーション、トランザクションを実装するためのZ-Scalerの先進的なソリューションをお役立ていただければと思います。本日の内容、ワークロードコミュニケーションのセキュリティに関する詳細は、弊社 Z-Scaler のウェブサイトでもご確認いただけます。また、イベントのアンケートにご協力いただき、イベントの内容や運営等に関する感想をぜひお聞かせください。次回のイベントをさらに充実するために、皆様からのフィードバックをお待ちしております。本日の内容にご興味をいただけましたら、ウェブサイトまたはアンケートよりお気軽にご連絡ください。今後とも Z-Scaler をよろしくお願いいたします。